This is a sectional question, question number 4. Identify which, if any, conditions of equilibrium hold for the following. There are A, B, C, and D cases. And now let's remember the conditions of equilibrium. Conditions of equilibrium. There are two conditions. One of them is translational equilibrium. Translational equilibrium must be provided. Second one is rotational equilibrium. And translational equilibrium exists if the net force acting on the object is equal to 0. Rotational equilibrium exists if the net torque acting on the object is equal to 0. But this is easy if object is at rest. You can understand net torque exists or not. But there is one more practical way to understand if an object is in equilibrium or not. It's acceleration. If net force acting an object is equal to 0, which means linear acceleration of this object is equal to 0. If net torque acting on the object is equal to 0, angular acceleration of the object is 0. Yani if accelerations are 0 for an object, in this case you can say that yes, this object is in equilibrium. Linear acceleration is 0, translational equilibrium. Angular acceleration is 0, it is rotational equilibrium. Linear acceleration can be 0 both two cases. One of them is velocity can stay constant. It does not change for an object which is in motion. Or velocity can be equal to 0. If velocity is 0, if velocity is 0 or if velocity is constant, which means acceleration is 0, then translational equilibrium exists. But angular speed 0 means angular acceleration 0 means angular speed must be constant or angular speed must be equal to 0. Yeah, angular speed mustn't change. If angular speed does not change, which means angular acceleration is 0, in this case, you can say that there is rotational equilibrium. Basically, no equilibrium, no acceleration, yes equilibrium. Yes acceleration, no equilibrium. This is the case you can remember practically. Yes equilibrium, no acceleration, yes equilibrium. Okay, if one of them exists, if acceleration exists, equilibrium does not exist. Okay, let's answer the first one. A bicycle wheel rolling along a level highway at constant speed. Keyword, constant speed. Speed is constant. So, which is, if speed is constant, which means there is no acceleration. There is no linear acceleration. A is 0. If linear acceleration is 0, in this case, translational equilibrium exists. Translational equilibrium exists. So, no linear acceleration, yes. Translational equilibrium. For a rolling bicycle wheel, we learned in section 2, chapter 1 that these linear speed and angular speed are related by r times omega. If this is constant, if linear speed is constant, which is also tangential speed, angular speed must also be constant for a rolling object. If angular speed is constant, which means no angular acceleration, because angular speed is not changing. Angular acceleration is 0. If angular acceleration is 0, no angular acceleration, yes, rotational equilibrium. So in this example, we have a bicycle wheel rolling along a level highway at a constant speed. When it says constant speed, both linear speed and angular speed is constant. For that reason, both linear acceleration and angular acceleration is 0. No linear acceleration, yes, translational equilibrium. No angular acceleration, yes, rotational equilibrium. A bicycle parked against a curb. Parked. What does parked mean? At rest. At rest means velocity is zero. If velocity is zero, angular speed is zero. No change in velocity, no change in angular speed. So in this case, both equilibrium exist. Even you can get by the force and torque. If an object is at rest, which means it is not speeding up, it just stays. So both rotational equilibrium exist, both translational equilibrium exist if it is at rest. This is the condition for at rest. If an object is at rest, you can say that both translational its equilibrium, because net force acting on this object must be equal to zero because it's not speeding up, and net torque is equal to zero because it does not start rotation. So both equilibrium exist. Yes, rotational equilibrium. Yes, translational equilibrium. This is the easiest one. For an object, park means at rest. For an object at rest, both conditions of equilibrium hold. But C is opposite of A. In A bicycle wheel was rolling at constant speed, but in C, it will brake. The tires on a braking automobile, wheel is slowing down, because if an automobile brakes, what does it mean? Wheels are slowing down. That's why it's braking. Slowing down, which means according to the equation of V and omega, because V and omega are related, if V is decreasing, slowing down means V is decreasing. Omega also must decrease. Omega of the tire also decreases. So if linear speed decreasing, there is linear acceleration exists. Yes, linear acceleration. If angular speed is decreasing, yes, angular acceleration. If angular acceleration exists, no rotational equilibrium. No rotational equilibrium. If linear acceleration exists, no translational equilibrium. So decreasing angular speed means yes, angular acceleration. So if angular acceleration, yes, no rotational equilibrium. Decreasing tangential speed or linear speed means there is an linear acceleration A. If yes, linear acceleration, no translational equilibrium. Okay, so basically, if you check these two exercises, C and A, you will see that for a rolling object, it can be a tire or it can be a cylinder or a sphere. For a rolling object, both equilibrium exist at the same time or do not exist at the same time. For example, in this example, C, no rotational equilibrium, no translational equilibrium. Both are no. But look at A. It's also a rolling object. A. In part A, yes, translational equilibrium, yes, rotation. Both are yes. Then you can keep in your mind like this. For a rolling object, if one equilibrium exists, if translational equilibrium exists, rotational must also exist. If translational equilibrium does not exist, rotation also does not exist. Both exist at the same time, or both do not exist at the same time. No, no, or yes, yes. But for rolling object, don't forget, rolling on a surface like a bicycle wheel. But there is a D choice in here. In D choice, the football in air, traveling in air, it's not rolling. Football is not on the ground, it is in air. If an object is in air, it's not rolling. So let's say about the football traveling through the air. So there is, of course, if an object is in air, if you throw an object into the air, there must be a force acting on this object. If you drop an object, which force acts on this object? It's gravitational force, is it? Gravitational force is the force which is acting on this ball. Yes, there is a force, there is a net force acting on the ball, which is gravitational force. If a net force exists, so no translational equilibrium, because remember, translational equilibrium means net force acting on the object must be equal to zero. But in here, it's not zero. For an object which is traveling through the air, gravitational force is the net force acting on the object. If net force acting on object is not equal to zero, no translational equilibrium. Even you can get by the acceleration, because every object in air accelerates with free fall acceleration g, which is 9.81 meter per second square. If acceleration exists, translational equilibrium does not exist. Yes, linear acceleration, no translational equilibrium. So this is translational equilibrium does not exist. It is easy by two ways, because there is a net force acting on the ball, which is gravitational force. There is also this ball is accelerating with free fall acceleration g. If acceleration exists, no translational equilibrium. But rotation, what about rotational equilibrium? Gravitational force cannot start the rotation or cannot stop rotation of an object if you throw an object in air or drop an object. Just hold an object in your hand and release it. After you release, you will see that this object is just falling down. It does not start spinning, or it does not slow down in air. Just it falls down, because gravitational force cannot produce a net torque for an object in air. So for that reason, no change in angular speed. It does not speed up. It does not slow down in rotation. So no angular acceleration. So no angular acceleration. Yes, rotational equilibrium. So then you can say that if you throw an object into the air, it can be a ball, it can be a pan, or it can be any object in air. So in this case, translational equilibrium does not exist because there's a net force acting on this object, but rotational equilibrium exists because gravitational force cannot speed up an object or cannot slow down an object. So these are four parts, A, B, C, D, which are very important in ministry exam. So they can ask to you again this year. If you check ministry exam questions, you can see that in what type of questions are asked about these four cases.